This is how an anticyclone looks, right? And they're quite large and they're hard to see because the part of them obscures their eye wall, which they're usually kind of sort of side on. As you can see, this is low and up and around, and all of this stuff gets thrown up and it folds in, right? And you can see it's going around, and it's pushing air into this one, it's pushing air into this one, like that. And when I stop the animation, you'll see what I mean, because it does all the wind currents, and they're quite big, and they go very slow on the insides, but they go a lot quicker on the outsides, right? You can see here, the anticyclone, and how you can actually see how the winds are feeding into this, the winds are feeding into this, and even here, look, it throws it up here, and then some goes this way. You see it's turning this way, and then some goes this way, and then it feeding. There's a low up here that it's now feeding. Alright, now I'll zoom in on here because that'll wreck the animation. You get an idea of how the densities work a bit better, because that's quite, a little bit more obvious, isn't it? There's a, and the size of it. Anyway, it'll probably take about another 3 days to get to places that's going to worry the East Coast. El Nino affects us more because the air currents are coming this way a lot, and sort of we see stuff almost forming in Western Australia, but it seems to go away because the El Nino cuts in and wrecks the East Coast. But yeah, again, I don't want the videos to be too long, so but the anticyclone here is pretty important. If you're looking at zoom, it's quite often you don't see them unless you zoom in on them. You specifically know where the anticyclone is and zoom in on them, and it shows you how the winds currents work with them.